So in the last episode we did sprites and meta sprites, so we could move Rusty around the screen. We did this with just dumping all the code in, and now I think it's time to just clean this up and get some basic background going. So there's a lot to tidy up here. Let's first just chuck in a background I've made. So I've just made a single page quick level with just, a couple of things we can start practicing physics on. So we just import that. I've already done the normal export scripts and made a tile set called tile set level. So you know how to do this now. We just do the set background data to set the actual tiles firstly. Start at 0, we'll go to tile set level size, and we'll pass in the tile set level. So this will load in background tiles, and then we want to set the actual background. So set background level map. And to do that again, set background tiles. And we just want to do full screen. So it's 20 tiles by 18 tiles. And the tile map for the level. So that should give us the background now of the actual level. Oh, passed in tile map level, not tile set level. Let's try that again. And there we go. So now we have the level. We've obviously got, we can move anywhere at the minute. There's no sort of blocks, but there's a nice visual. So that's the background done. And what we're going to start doing is moving all this out to functions. So it's cleaner in the main setup. So for now, we'll just call it setup background because it's a small application and that's all we're doing. We're not doing anything fancy, so we don't need to really obfuscate it much more than that. And then now we can simply call setup background. So this is cleaner. Now the character's a lot more work. So we want to, instead of having just all these random numbers and random maps, this wants to be all grouped together in an object in a sense. So in C, that's a struct, whereas in like C# and C++, you'd probably use classes. But for basic C, I'm just going to use a struct. It's got what we need for now. So we'll make a new folder, call it structures. In there, we'll make a new file, we'll call it character. And in this, we'll want some headers. So we will want these headers here, the basic ones. And we'll also want to include the structures character header in the main file so we can access it. And now what we want to do in the character is create a type definition. So instead of having, say, a uint, where we define variables like this, which is just an 8-bit number. So to do that, we just do struct, and then we'll give this a name, character, and then at the end, it needs a reference name. So we'll do character again. So now we can chuck properties in here, such as, say, the sprite ID. And if we now want a main variable in the top of our code, so say here we can now reference character and call this player1. So now this creates a new instance. And we can access this and store all information in that we like. So say in main we wanted to access that sprite ID or set it, we can do player1. So say we wanted to access that, you can do player1 and then sprite ID and then equals say 1. It allows us to store and group all the information about a character in one place instead of it being split among files in different places. So with that in mind, let's make and fill out all the things we can think of about a character in here. So we need the sprite ID to know where it's stored in the sprite table. Because ours is a meta sprite, we're going to need sprite tile width and height. So that will allow us to then automatically, load in sprites based on expected size. We're going to support animation. So we're going to do sprite frames, which will be the number of frames that would animate. If we're animating, we need to know the sprite current frame as well, which will be defaulted to 0 to start with. We're going to need, I guess, the starting point of where the character lives inside of a tile set. So that would be tile set start, I guess. We're going to need the X and Y position of the character. So we'll just literally, I think just X and Y is enough for that. We're going to be moving around. So the character is going to have velocity and movement. So we're going to have vertical and horizontal velocity. So we'll do velocity X and velocity Y. And then we're also going to want to point to the actual tiles, so like these tile sets here, but we want to do that in a pointer. If we store a constant character array in the character, it's going to copy and clone this huge array every time. So instead of passing a copy of it, we want to pass a pointer to it, which means it references back to the original without having to store it in memory. We'll just do the const unsigned character, and the difference when you have a pointer to a character array. So a quick breakdown is when you do this, it's effectively the same as doing this, but this is a pointer to the first entry only, and then you can reference after the first entry to get to the next entry. So when you see the arrays, it's for type definition only, not for pointers, and effectively you can swap this for just a pointer and we'll call it tile set. So you'll see this used after, and now if I just comment all that, including the character, we can now start doing something with this. So we now have the player one, and let's scroll down and see what we do next. So we would want to move all of the setting up of the sprite, the moving of the character in a setup function. And to do that, we will need to know about the tile set Rusty, we'll need to know about the width and height, the animation frames, the things we haven't implemented yet, but we want to. So let's jump back in character and make a function inside of here, so everything about the character is in one place. It won't return anything, but we'll just call it setup character. And inside here, if we pass in the character, and again, if we use a pointer to the character, so as we're editing the actual structure, not a copy of the structure, we'll need to know the sprite ID, so we can keep track of it when we need to do future things with that specific character. We'll need to know the width, tile width and height, and this will be needed for when we're loading in the sprite to know, how many steps we go in the X and Y direction to automatically load the sprite in, as well as animation. We'll need to know the tile start, so the tile set start. We'll need to know the number of frames for animating, so total frames. And finally, we'll need the tile set passing in, which if you remember was a const unsigned character pointer called tile set. And if we go back into main, let's just call this now. So setup character, and let's just pass everything we know we will need. So that will be the character itself. So we want to pass the address of the character because we want to pass a pointer so that this exact character gets edited, not a copy of the character. The sprite ID is 0. The tile width is 4 by 4 because it's a 32 by 32 pixel character. The tile start is 0. The character frames is going to be 9 because we actually have 9 frames of animation. So we might as well set it here as what it will support. And then we need the tile set Rusty going in, and we don't need to address this with referencing to address because if you remember what I mentioned, when it's an array, it already is a pointer. It's a pointer to the first entry in the array. So that would be everything passed in, and that's all we'd need to then specify to setup character. In a similar fashion, if I comment that, it's much easier to see what we're talking about. And now we know with what we've passed in, so long as we've set the tiles already here, so the sprite data, we should be able to move all this, the move and everything into here. So now instead of doing this, we need to do some setup first with the information we have. So let's first reference everything we've passed in and link it to the character. So the character is aware of all this because the character is currently blank. So the first step is to link all the properties we've just passed in into the character. So because the character is now a pointer to the character, this would be accessing the pointer. So to dereference, we do a minus and a greater than sign, and now it's the equivalent of doing character dot on the character like this. And you can see the autocomplete's actually smart enough. If we do character dot and hit enter, IntelliSense is automatically dereferencing for us. So if you want to type quicker, we can do character dot tile map and tab, and then just be aware that you shouldn't be doing dot, it should be this when it needs to dereference. So as long as you're aware of that, you can just do the quick character dot to autocomplete, but do remember it does need dereferencing. So the tile map is the tile map, which I've actually called tile set by mistake. And this is where the character lives, mapping to what we know is in the sprite table. The tile start will equal the tile start. And again, that should be tile map start. And in fact, to be honest, in a tile map, you probably would never have a different position, but might as well support it. And you get the idea for all the others. Let's just link all these and comment them. And there we have all of the variables now pushed into the character struct, so it knows about all of these things. So we haven't done anything new yet. All we've done is created a character structure that is a bunch of information that we know the character will need when we finally come to do something. The first thing we now want to do is actually load in the sprite and move the sprite to a certain position. So the moving will probably happen after as a separate call, because why would we move when we're setting up? So that will be moved out to another call. So let's just move this set sprite first. This will be a default. And bear in mind, when we are animating, we're going to have to call this all over again with a different reference here to the next frame. So all this wants to be its own function. So let's cut that out. And because we're just using a single header at the minute, I'm just going to dump above so that the setup character can find the other method. So let's make the function, and we'll call it load sprite, or load sprite frame, I think is probably the correct term. We'll pass in the character pointer again. And that's all it will need, because the character holds the current frame. So if we're telling it to load the sprite frame, it should just load the current frame. If we want to change the frame, we should simply change the current frame and then call the load sprite frame. You could change this to do it in one step. So load sprite frame, and you could do frame here, and then you can set the character dot current frame equals frame at the same time, and now load in that frame. And that probably makes sense. Otherwise, you've got to set the current frame and then also load the frame. So this will go, and we will actually just call load sprite frame on the character, and we want to load 0. So this will take care of setting the variable and loading the sprite at the same time. So load first sprite frame. Set current frame. And then you can see how we currently did this, which is to set the sprite from 0 to 15, and with the tile map of Rusty. So this couldn't be any simpler now, because we have all the information we need to automate this. So all we want to do is work out the total count. So sprite count, and that's as simple as the character tile width times the character's tile height. So obviously 4 by 4 is 16. Get total sprites. Now we just loop those sprites. So we do for uint8 I equals 0, and then normally you do while I is less than something, but for efficiency in C, you can just do in the next step, do more than an increment or something where this would ever get skipped, you're fine. So because we're only incrementing in 1, and we know we will always hit this, we're safe to do it isn't equals than. It's just a little bit more efficient for code. We move this into the frame now. All we've got to do is replace this with the position we're at. So remember, we had a character sprite ID, which is obviously the ID of where this starts. So we need to do that plus the I, which is then 0, 2, and in this case 15. So if we started with a sprite ID of 7, it would start at 7 and add 15 to it. So we're making sure we load in the character sprites one after the other, starting at sprite ID. The tile map's already now stored in the character as a pointer, so we can access a tile map like this. And then now instead of 0, in a similar fashion, we just need to do the character's tile set start, which is actually named wrong again. It's tile frame start. Tile map start even. Get that right in a minute. There we go. So tile map start, in case we have an offset in there, and then simply plus the position again. And that's all there is to now, instead of having individual ones, to just loop over starting at 0 and just load in the tile map for that character. In order to support the current frame, we want to offset by that frame. So say we're on frame 2, what we're going to expect is the tile map would have the first frame in a row, then the next frame in a row. So specifically, this tile map here, here's the 16 bytes that refer to the first animation frame. If we wanted the next animation frame, we'd expect it to be right below here. That's frame 2, frame 3, 4, you get the idea. That's what we will do when we come to do the animation. So we want to just make sure that in this position here, where we're loading from the tile map, that we also want to add the current frame, so you might as well just use frame because it's passed in, times the sprite count. So you want to include a jump of 16, in this case, every time you move frame. That will then support animation naturally, and all we'd have to do is load the next frame. So that should take care of loading the sprite. This move we mentioned we're going to do elsewhere. It's not to do with setup, so that's the setup all done. So you can see there then we now need to, after setup, move the character. So move character, and we'll pass in again the address to player 1, and we'll move him to, I don't know, somewhere like 64 and 100, so somewhere near the bottom. Not being very accurate there, and we don't really care for now. So move character somewhere. That's literally what we're doing at the minute, so that'll be fine. And now we will want another method called move character. As always, a character pointer to the character so we know what we're doing. And we'll want the position we want to move to, so the X and the Y. So again, just like the load sprite, let's first set the character's X position to equal the new X and the character's Y position to equal the new Y. So set character's new position, and now we just got to move the character. And this time, because the sprites will be based on both an X and a Y axis, it could be 7 long, 1 down, we'll need 2 for loops for this. So we'll do an I, or in this case we might as well do an X, let's name it correctly because it's got some relevance now. And X is, remember, not equal to, and we've got the character's tile width. And then inside that we'll do 1 now for the Y, so we'll iterate over the X first and then over the Y. So Y isn't equal to character's height, Y++. So now we have a double for loop. So it will come through the X will start at 0, then it'll come to the Y will add up from 0, 1, 2, and 3, and then it will go back, and X will increment to 1, and then Y will go 0, 1, 2, 3. So we will be loading going down. Now more conventionally, I'd think of it as going across. So I'd load, like we've done here, X going across, and then down and across, down and across. So if you want to do that, just for whatever sake makes it easier to think about of what's looping, you'd flip it around like this. So the X will increment first across, and then the Y will jump down, and then we'll increment again. We know we're not going to need all these, we're going to need 1. And now our job is to simply figure out the new values in here. So this one's easy. This is the character's sprite ID, if you remember where it starts, plus now the X, so going 0, 1, 2, 3, and then plus you can't just do the Y because every time you move down a line, X is now 0 and the next line would be 4. So if you imagine the first line, sprite index 0, 1, 2, 3, you jump to the next line, it should be 4, 5, 6, 7, 8, 9, and you get the idea. So if we do X, which is 0, and it goes 0, 1, 2, 3, we're fine there. Y increments to 1, and X goes back to 0. So at this point, we need 4. And the only thing we have is 1 and 0. So to get that, you simply multiply Y by the tile width. So we know every time we've come down a line, we're adding a full line to the value. So for that, you just do Y times character's tile width. And IntelliSense has failed me now. And that's because I've got all that above. So that should now give us the index, which if you want to see clearer, you can just do U8 index equals like this. Depends if you want to, see it clearer. calculate sprite index, and then you can put the index in here. Next up, you need the X position. So that's simple, it's always the same, and it's based entirely on the X position. So that will just be the character's X position, or in this case, we've passed X in. And one thing you'll notice here is to be careful of, and something we've done by mistake, is the X and Y variables passed in, we've reused as this for loop. So we'll actually call it IX and IY, just so we know it's part of this loop. So that's the index of X where we're currently floating through. And then we just need to make sure these match up. And then it's clear which ones we're using. So in here, you can do the character X, or you can just use X because it's passed in. It depends on which one you want to do. I'm just going to use X because it's shorter. So we want to move the character to where it says, which is the simplest, the first index. So, 0, 0, it would just move to where we said, which is correct. But then every time X adds up, we need to add that position. So every time the index of X adds up, we want to add 8 pixels because a tile is 8 pixels. So we simply do X plus the index of X. And for the Y position, it's pretty much a similar thing. It's based on the Y all the time. So it'd be the character's Y plus the index Y times 8. So the X and Y is based on where we're actually at, positional wise here. That should give us the exact same results as what we had before. And I think, let's see if it all compiles now, because we've removed the starter piece. There we go. So you can see that's all working and loaded just like it was before, and now we've loaded the pug down here. So that's cleaned up this file now. We have set up background, set up a character, which now we can call simple things like move character, and that will make things like this, moving the character around. So this really is, see, the problem with move is when we say move and the code's called move, it literally moves the character to that position. When we say move here, we're on about scrolling, but I'd say the character is moving. So it depends what you want to call this, but we're going to just call it scroll character because it, links with the sprite and it keeps all the naming convention the same. So we'll actually say scroll character. We know all that's not going to be needed in a moment. We just need to replace this one function. So we'll cut that, go into character as before, and we'll make one here called scroll character. And again, a pointer called character. And this time we want the amount we want to move in the X and Y. So it's the same parameters, but this time it will be the amount we want to move by. And we will do velocity and things when we come to scroll. It might be nudge, it might be apply velocity. We wouldn't probably scroll the character, since you're not scrolling. You're adding velocity, but we'll deal with that when we come to it. So for now, let's just do what we did before. And in this case, it would normally be the character.x plus the X position. But a shorthand for that, obviously just do plus equals, and you can add the X, character.y plus equals Y. So this will add the difference to here. And now we don't need to do anything with scroll because we can just set the character direct again. So instead of even using scroll, we can just for now use move character. Obviously, when we come to do velocity and things, this will resort back to being a different function. But for now, the way we are technically scrolling, we can just reuse the move character. So all we do is set the character different and then move it. And then it's just going to reset it to the same thing here before doing the actual move. So with that done, we should now just be able to say scroll character, the address of player 1, and the move X and move Y. And move character implicit declaration, too many variables. That's because we're currently using one header and scroll comes after or before move. So let's put it below move for now. And this is the purpose of having C files and header files. So your functions can be in any order, but for now we'll just leave it as the one. So let's try that. And now you can see it's mistakenly moved up there. So we've got a bug. And it's because we've passed in the X and Y, not the character's new X and Y. Let's try that again. And there we go. We now have the exact same thing we had before, but with a nice background and cleaned up and commented code. So we've now got in a character file that probably now needs to be a C and a header file, but we'll again do that as we go, do it in steps. We've defined a character and we've defined a bunch of functions the character can do. This keeps this code much cleaner and much easier to see. And you can even go further now as to say this button reading function and scrolling character could all be wrapped in another function that's called something like, link character to joystick or something, or even just enable joystick control in the character, because it's a universal method we can pull in this joypad. Because if you go to joypad, it's just in the gb.header file. The character has access to that. So this character could automatically just say, be called with another function. So we could simply make another function that does all this, that needs nothing, that could just be called void move character with joypad. We might as well do that, I guess. Move all this over, and then the logic could stay in there. And this could just become move character with joypad. And again, address to player 1. Go into here, pretty much paste everything in. Everything should already work. This just wants a character pointer called character, and that's it. And then all we need to do is replace the character here in the scroll character with our actual character. We can pull the joypads in anyway, and we can move the buttons. That keeps our code loop and our main loop of what's going on very clear and nice and broke down. Let's just try that. Implicit declaration again, because we keep putting these in specific orders. If we want to use scroll, it's going to have to come after. And you can see we'll soon get at a point where we have to make a header file for this, because this will end up having dependencies in the wrong order. So again, something else we'll clean up as we're going. And there you go now. We have all the same functionality as we had, nothing new, but in a much more cleaned up and reusable way. So if we wanted now 2 pugs, all we have to do is copy setup character, pass in a new player, a different sprite ID, at least 32 in front of that because of the size, and then we can just call move character with joypad. So let's just prove that, just for a real quick show off of what this does. So if we just make a clone of setup character, pass in player 2, sprite ID of 32 because there'll be 0 to 31 tiles for the other one, same tile map, exactly the same, move the second player, and they're going to move the same, so let's just put this one up and further over, something like that, doesn't really matter where. And let's have them both move with the joypad. And if we do that, we should see 2 Rusties on screen now. And obviously not. And I believe it's the sprite ID, because the ID isn't the number of sprites in the tile, it's actually the number that the character uses. So you can see here the Rusty tile actually uses up to number 15. So we need to start at 16, not 32. Otherwise, I think we overflowed. You can only have 40 on screen at one point. And then let's see if that fixes. There we go. Now we have 2 Rusties moving around. And you can already see the issue we're potentially going to have with a Rusty this size. Look at how many tiles we have left. We've got like literally a handful there. So this sprite is going to be super limiting to what we can see on screen because we have practically none left. So we might have to reduce this when we get to any kind of serious game and make a smaller Rusty bug. But that shows you how to clean up and make your code much more reusable, and how easy it is then to chuck new players in and do things with, making use of this character going forward. So that's it for this one, guys, and I'll catch you in the next.